set of models. So to start off with, just a bit of context about why we need to do it. So the New South Wales government signed up to implement the floodplain harvesting policy in about 2013. And the purpose of this policy is to ensure floodplain harvesting diversions, that is water take, within a river system, so that they are at or below the legal limits. This is to ensure that the environment is protected and also ensure reliability for downstream water users. So the floodplain harvesting policy are implemented on the 5 northern valleys within New South Wales, and this policy requires a licensing framework. In order to implement the licensing framework, what we need to come up with is a volumetric entitlement that will work at individual scale. And in order to do so, we will need a model to estimate how much is actually taken as floodplain harvesting and how much to be managed. So before moving on, the river system models that I'm referring to as part of this project has 2 main components. The first being the physical processes that are representing how water moves within a catchment. So this includes things like runoff, storage routings, water being taken as diversion, and how flow sort of goes from upstream to downstream. And what we built on top of these physical processes are also the management layer, where we implement the overarching management rules in the catchment. This is typically the water sharing plan rules, but we've also included other operational aspects of how the catchment is being managed. So things like bulk transfer between the regulating storages, as well as some of the accounting rules in the water sharing plan. So I won't go into too much detail in that regards. Moving on, so the challenge that we have is that the modeling team has the responsibility to come up with the volumetric entitlement. And as I mentioned before, this is being rolled out in 5 northern valleys in New South Wales. And out of the 5, we actually have 2 models in source, namely the Namoi source models as well as the Border River source models. The department has had river system models that have been developed since the 1990s, and these were mainly done in IQM. These models have been fit for mainly in the context of policy and planning development, but also diversion compliance. However, the healthier floodplain requires us to come up with a volumetric entitlement, and there are limitations in the existing model as to how much or how good we can estimate floodplain harvesting take. So this calls for an unprecedented details and geographic scope in the model itself. So the 2 biggest limitations in the existing models are that the farms are being lumped or aggregated within a river reach as a one water user node, and there has been some uncertainty around about how the system loss has been estimated. So typically the system loss is calculated by looking at the difference between the upstream and downstream flow gauge as well as known processes in between. However, as part of this exercise, we're putting a lot of attention to details on how the high flows are being represented in the model. So this will reduce uncertainty, but not eliminate all of it. So we will need an enhancement to the modeling. The next slide I have has got a bit of detail there. Sorry. There's a bit of a detail here, but I won't go through everything. Just like to point out how the models have been set up and configured. So basically, we have started up with a farm scale model where we put in a lot of details on how each farm is being managed, what sort of infrastructure is available, and how they're using water to water their crops, and how it tries and get water from the regulated dams. And from the farm scale, we move on to the reach scale, where we also look at flow routings, breakouts, and high flow effluents, and how these high flow effluents are able to be accessed by each individual farms. And finally, we go into the river system scale, where we implement a lot of the management rules, such as the accountings and allocations. So just to give a bit of a broader background, I guess, on the scales that we're configuring the models on. So we're putting a lot of attention to this healthy floodplain project. As a department, as I mentioned, we've had models have been developed since 1990s, and we've got a concept of living models in which we continually improve upon its accuracy as more and more data became available. But the healthy floodplain project actually calls for a jump in terms of its capability, and this required us to do a complete redesign and upgrade of the model itself. So as I've mentioned before, there's a limitation in the existing model where we simplified the processes within a ridge. So you might have a ridge where there's a few irrigator or water users within the ridge, but we have in the past aggregated them as one water user node. And in terms of uncertainty about the losses as well, this system loss typically includes other components like transmission loss, unmetered usage, floodplain breakout, as well as mass balance corrections. Um, what we have now as part of this exercise is that we are representing each individual farm separately in the model, each with its own unique access on how the farm is being managed, but also unique access as to which high flow effluents it actually has access to and how much it can actually take. The losses within the river ridge has also been further detailed, I guess, where the floodplain or high flow effluents are explicitly represented in the model. This is just an example of the hydraulic model schematic that we have been able to utilize in the Lower Namoi floodplain area. And you can see how even within a ridge, the high flow effluent may occur at different locations as well as different flow paths. So in the model, we're able to represent each of these individual farms separately, and we set up the model so that each individual farm has access to different breakouts as they are available, as well as different points of access. So as a summary, we've done a lot of key model enhancements to the models, both conceptual and non-conceptual. So conceptually, we are representing each individual farms rather than grouping them within a ridge. We are also representing high flow effluent explicitly in the model rather than being lumped as part of the system loss. Because of the high details on where flood runner are occurring and where it's actually flowing to, we also are able to define the order of access for a number of these properties. And that determines what level of access they can actually take as part of their farm and harvesting. Within the farm scale, we're also putting more attention as to what areas to have in their farms. So the bigger categories are developed and non-developed areas. Within the developed areas, we have either the crop areas as well as the non-crop areas. The advantage of having these explicit or different categories within the farm scale is that we're also able to quantify runoff harvesting within the farm better and have a more complete sort of water balance within the farm. As part of this work, we're able to configure the model with more accurate infrastructure details. So this is a big project where we're also collecting a lot of farm surveys to the impacted landholders. A number of the department staff have also gone on and done on-the-ground inspection. We're also utilizing new things like remote sensing to cross-validate our model setup and results. As part of this upgrade, we're also able to have more complete representation of farm water balance. So we are considering all water sources that are available at each individual farms. Some farms might have access to groundwater, some farms must have access to unregulated creeks. Those things are more detailed in this new set of models. We've also improved representations on various on-farm processes itself. So things like storage and irrigation losses, the use of different types of storages, such as permanent storages, surges, temporary storages. And we've also taken standardized approach on looking at irrigation application rates. So you might think that we have made quite a bit of changes to the models, but in actuality, the total water balance should remain the same. The inflows don't change, the meter diversions don't change, the flow that remains within the river also don't change. What we've done is better repartitioning the system loss into the lower loss as well as the floodplain harvesting components. So as a summary of the model upgrade, we have used best available data in the model. We've used published or verifiable data wherever possible. There has been significant amount of quality checking as part of this model build. And as a result of this work, we have a comprehensive and robust model where we can look at farm scale water balance within a well-tested river system model framework. So this has been a long journey, not just for the department, but also for the modeling team. This work has been well documented and also independently reviewed to gain confidence when we do go out to stakeholders for engagements. So these models are ready and are currently being used to determine entitlements as part of this Healthy Floodplain project. Okay, so under the Healthy Floodplain project, we needed to implement significant model upgrade. What do we do now? We need to calculate entitlement that can be issued to each landholder, and the way we do it is by looking at a number of different scenarios for compliance purpose. So for those who are not familiar with the water management in New South Wales, most of the valleys or inland, most of the valleys have got water sharing plans in place, and the water sharing plan states the level of diversion of water take within a river system. This is what we call a plan limit scenario. This is actually based on the minimum of the two development levels. There are cap conditions around about 93, 94, and the water sharing plan conditions when water sharing plan was actually implemented. We need to come up with a current condition scenario. This current condition scenario is meant to represent what is actually on the ground at the moment, and we know that each individual farm has been working on improving its own efficiency as well as increasing capacities and changing pumps and so forth. So we need to come up with a current condition that estimates how much floodplain harvesting can actually be taken as of now. If there is a growth in use, then we will need to introduce licensing framework to bring total take back to the plan limit. So the licensing framework that we are introducing are a two components framework. The first being the entitlement or shares itself, and the second being is the accounting rules. So the two work together in managing total floodplain harvesting take. So this graph is a graphical representation of the different scenarios in the previous slide. So suppose we have X megaliters of floodplain harvesting within the valley, and if we build the current condition based on the eligible works and our base model, it seems to suggest that there's a 10% increase in floodplain harvesting take. We will need to come up with a licensing and rules that will remove this growth and basically legalize what they are taking back into what they were allowed to take under the plan limit. So this is a time series representation of the intent of the licensing framework. So the compliance is based on long-term average, which is the blue line here under unconstrained case. under the licensing framework, we're expecting to see a reduction of the long-term average take, which is represented by the red line here. And as you can see, because the compliers are being managed at a long-term average, the impacts on different years will be different. So some of the wetter years might be impacted more than the dry years. Some of the wetter periods where floodplain opportunities occur almost every year, they're also more highly impacted. To finish off, I guess, a bit of a summary. I guess the slides are really there to share our experience on how we have used detailed river system models to help policy and implementation problems in the context of healthy floodplain. As part of this project, we had to do significant model upgrade, which are mainly the detailed farm models, as well as putting a lot of attention into representing high flow effluents better. And we are now able to use this set of models for various scenarios, initially for floodplain harvesting entitlement, but can be used for a number of different scenarios that might come in the future as well. I think that is it for me. Any question?
Thank you, Michael. There are a couple of questions, and I thought, if I'm wrong, then please just say, but I thought you might actually be able to answer one of the late questions that came from Catherine. Is there an easy way to import farm dam area from satellite data? You mentioned remote sensing. Did you have to do that?
Yes, so we've also used LiDAR to have a look at and cross-validate the farm dams capacity, and we are looking at both the areas and the volumes using satellite imageries. Sorry, from LiDAR. I haven't actually processed the data myself. I believe that the department has contracted this work to a consultancy, but at the end of the day, what we have is really just a table of capacities of the farm dams. And as Catherine has suggested, can't stress enough how helpful the scenario input sets are. We're able to pre-process all of those data outside of the models and bring a whole bunch of information in the model in one hit of a button, really.
Excellent. All right, then. Well, if you still need more, then perhaps find Catherine at the break. We have a question from Christopher Carroll. Do you see any potential to consider the effectiveness of constructed wetlands on water quality from farms?
Yes. However, at this stage, the model hasn't been set up to look at water quality yet. The Healthy Floodplain project has been really focusing on trying to quantify the floodplain harvesting take itself. This has been a very contentious or debatable issue. I guess no one has been able to say with confidence of how much floodplain harvesting can actually be taken. There's been some estimate about using satellite imageries and what sort of before and after kind of thing. But this is, as far as I understand, this has been the most comprehensive work where we need to come up with a proper estimate of how much is actually taken, not just how much is actually occurring in the catchment, but how much is actually taken. Yeah, so I'm not really sure if I answered that well.
Christopher can grab you in the break as well. The last question from Nadika Minaj, apologies if I pronounced that incorrectly, probably flows on from your last comment. How did you calibrate these models?
We can talk for about 2 hours on this. I'm happy to talk about this in more details, but as I've said before, we take a three sort of broader approach there where we do calibration at a farm scale. So we do consider the level of details on how the farm is being managed. And we also take into account, the different sources of water and how each farm is managing their water usage with, in the dry years and the wet years. But we also move on to the reach scale process where we're looking at mainly recorded flow gauge and have a good flow calibration in that sense. And we're also calibrating it at a value scale. So we're calibrating towards, resource assessment, making sure that the model is simulating the right level of allocations and things like that. So there's a lot to cover there, but I'm happy to talk in more details. Nadika.
Sure. I think they can have a long coffee break chat with you then.
Yep.
Alrighty. Well, that's all of those questions. I was slightly curious, maybe it's along the lines of Chris's, about how it might work for natural wetlands, if there were some lessons here that we might be able to share with the environmental water managers.
So I think wetland is a good sort of issue that we need to consider here as well. As part of this work itself, what we are still lacking, we are able to quantify how much has been taken into the farm dams, but what we are still lacking is the estimate of how much return flows we are getting. So this includes things like if there is a wetland within that floodplain breakouts area, how much of that actually remains within the wetland, or how much of that actually goes into increasing the groundwater levels, how much of that is actually returning back into the river. So there's a bit of a gray area in that sense. Not sure if we are ever going to quantify 100% everything. I think there's still a bit of work that needs to be done in that space as well.
Yep, excellent. Well, thank you very much. I will give a virtual applause from everyone in the crowd for you. We might, I will, there we go, I'll let you go back. Oops. Anyway, so we'll take a break now, and I will call you all back in about 15-20 minutes. So as I said, we want to, obviously it's hard to listen virtually for a long time, so we've given you lots of breaks, and we're also keen to try and replicate the face-to-face experience that you're missing out on. So please move around, make new friends, catch up with old friends, grab a drink of water, and we'll see you again at about 2:25.